So if you have any questions, please write. My chat box is open. I will be monitoring the chat box during the lecture. Today, we are going to discuss and see what do we have special things in military, in defense grade computers and defense computing. We will have some videos within the presentations. So I hope you will have some good time in the lecture. So the computers have significant role in military. Actually, the reason for having a computer goes back to Second World War for coordinate computations and code crunching. So today, it is one of the essential components of military, having good computers. Why do we have such a requirement? Because we have a lot of tasks as follows, such as analyzing intelligence information, embedded computing and control, vehicle control and guidance, avionics, aviation electronics, meaning organizing data for leadership, geospatial analysis, smart weapons, communications, simulations, surveillance, target calculations, etc., jamming, etc. So, since it is so crucial and to protect the nations, the aim is to protect nations themselves, cost is not a significant option. Therefore, people build very powerful systems, very high quality systems for military purposes. On the other hand, sometimes some weapons might have very simple and cheap systems. If they are designed to be like a kamikaze type of system, only one-time use, and then it will be gone after that. So different characteristics are required for military operations. Typically, a military computer is much more robust than an industrial computer. Most of the electronics will be protected in a layer of coating because of the environmental conditions or because of the jamming from the radiation, jamming by radiation from outside. And there is also structure inside to support the components, so hard components. Cards will be supported by additional connections, so they don't pop up from the sockets. Sometimes they are glued and screwed with additional measures. So there are droppings, explosions, shocks, etc. So vibrations. So military computers are therefore capable of enduring these shocks and temperatures, extreme cold temperatures and extreme hot temperatures. There are differentiations between military computers and office computers in general. One is the cost, target environment, availability, architecture, and features. They cost a lot because you don't produce them in large quantities in many cases, and there are more strict requirements. So if regular computer is costing 1 unit, 1,000 Turkish liras, A military computer can cost 20 or 10. So not 2. Consumer computers from manufacturers such as Dell are manufactured in very high quantities, or Lenovo is very high quantities. That will make the cost lower. However, military programs and military computers are manufactured in very small quantities, like 20, 50, 100, etc. So they will actually manufactured by hand sometimes. So that will drive the costs up. So they are expensive because of the manufacturing numbers and also for the requirements. They will be constructed using more robust materials, different chips, different chipsets that are endurable for higher temperatures. Those chips will be more expensive. Those capacitors will be more expensive. Resistors will be more expensive. Then everything will be more expensive. Power supplies also. And the target environment is not the office or system room. Target environment is inside the tank. So tank is a very hot space. Their extreme temperatures like -60 to +65 degrees ambient temperatures and chip temperatures up to 125, 150 degrees rather than 85 degrees. So humidity levels and dust levels are very critical. They may be required to operate in high salt environment, like in a ship, military ship. So isolations and board design and enclosures are kind of different. Sometimes they are intended to be used in the aircraft for less pressurized environment. One of the interesting thing also in space, one of the interesting thing people say about American space devices and Russian space devices is Russian space devices are have been using computers and equipment that are working in atmospheric pressure. Therefore, electronics are encapsulated in a pressure chambers. So all the electronics are encapsulated in round tanks, which are pressurized. Electronic computers, etc. So that is their philosophy. In United States, NASA designed all these electronic equipments to be operable in the vacuum. So the boxes are rectangular. Electronic boxes are rectangular because there is no pressure inside. Okay, but the Russians have round shapes. So when you look at the spaceships and the satellites and moon landers and Mars landers made by Americans and Russians, Russian ships are more rounded boxes. So when you look at the spaceship, you immediately recognize that it's a Russian made or it's an American made because American mades are rectangles all around them, but Russians are all rounded because they are pressurized. That was the reason. If it's a military device in some form of weapon, it will be required to operate in Afghanistan, in the Syria, etc., as well as in Siberia, in Ukraine, etc. So very cold and very hot temperatures must be carefully designed in the design phase. And military programs and military operations and military devices are longer than commercial programs, meaning that once you develop a weapon, it will be used for about 50 years. So the validity of a computer system is accepted about 50 years or 30 years, 50 years. So very long time if you compare it to consumer devices. Therefore, the robustness, maintenance, upgradability, they all are very important for successful systems. So F-16 fighter jet was designed in 1968. So it is as old as I was born in 1969. So roughly F-16 is in my age, but it is still flying and it will be flying for the future. So long-term availability is very interesting. Military systems are capable of being used for a long time. As we see from the news, Russia is still using tanks from the Second World War. So Second World War technology is still being used in the playground. Therefore, a motherboard in a consumer-grade computer may have an availability in months or years, few years. In military computers, documentation and capability and the spare parts, etc., must be provided for longer term. There are different architectures, PC architectures, etc., but military computer systems are more designed in smaller and faster and more robust industrial setting, so so that they will be capable and expandable for cards. Sometimes the military computer is produced specifically for some application. So in that case, the card has special shape in order to fit into a certain device. So special arrangement can be done, maybe without certain cards or maybe multiple cards if it's a communication computer, etc. So special production is required. And there will be different features such as connectors like this. Instead of D-type connectors or USB connectors, military connectors are as follows. Fans are different, panels are different, displays are different. A lot of things are different. So military computers are tested in a rigorous way. So I am going to play a video about testing a computer system with explosives. Let me know if you don't hear the sound. So let me make sure that you are getting the sound output.
MIL-S-901D, the gold standard of shock testing. Chassis Plan's rugged military-grade 4U M4U computer system has been successfully tested to MIL-S-901D Grade A for use in the SPY-WAR NAV SSI rack. The test requires 4 shots or explosions in the water next to a barge in which the equipment is mounted. Thus, this is commonly referred to as the barge test. The explosives are 60 pounds of HBX-1 placed 24 feet underwater between 20 and 40 feet from the barge. The Chassis Plan's M4U computer passed the more rigorous Grade A requirement by continuing to function after all 4 shots without any repair or intervention. Grade A equipment is necessary for the continued functioning of the ship after an attack. It might be noted that the chassis plan's M4U system was a standard configuration and was not enhanced in any manner to prepare it for this punishing test. Chassis plans continues to support SPAY-WAR.
Okay, so the type of applications are quite interesting. I'm going to show you two videos. Did you get the sound okay?
Yes.
Yeah.
Okay, so here are two videos, short videos, one from BBC and another from NATO. Let's watch them so that we can get some understanding about what the requirements are.
Well, this is an early morning lull on board the Charles de Gaulle. Here on the deck, you can see the jets that are being used constantly for operations, flying day and night. These behind me are the more modern Rafale, but also the Super Étendard. These are the older planes. Now, there are 18 Rafale on board, 8 Super Étendard, and you can see the men during the day who make sure that they're going to work, make sure they're ready to fly. So the guys wearing red vests, you will see. Now, they are the weapons engineers. We're not allowed to show their faces. We're not allowed to show the faces of the pilots either. People wearing green, well, obviously I'm a visitor, but also engineers wear green. And the guys who are essentially in charge of the deck, they wear yellow. So they're the ones who will order the launch and the recovery of these jets throughout the day and the night as well. And this is how they launch the aircraft. You can still see a bit of the steam coming up from the steam catapults. There are 2 of these. Also behind them, part of the deck lifts to give more resistance for the jets to take off. Now, this aircraft carrier is about the deck 850 feet long, but they only use about 200 feet to launch. And they've got to go from 0 to about 150 miles an hour in the space of a few seconds. So incredible force being used and power to get these jets off as they go on their missions to Syria and Iraq. Well, this is essentially how you stop a fast jet on board an aircraft carrier. These cables, they have hooks on the planes which catch them. 3 cables across here. They try and catch the middle one. Often they catch the end one, and occasionally you will see a jet just go over because it's not going to catch them and then come back again. We're seeing about 20 sorties a day. Underneath this deck, of course, is all the mechanics for these cables, the arrestor gear. And even below that, then there are the lifts that take the aircraft, once they've flown missions, down to the engineering hangar to make sure they're ready for the next day. Now, the Charles de Gaulle has been doing this for the last 3 months. And of course, this just started days after the Paris attacks. So it's very personal for the pilots and the crew on board this mission.
So this is French ship. And this is what NATO base in Germany. So they are monitoring the European continent for threats, probably from the Russia and other similar countries, maybe from Iran. Let's see what they are doing, and let's see what are the requirements. This is more like office type.
We had in the old scenario always a calculation. The longest time you fly with a fighter bomber over Germany is if you go from the Czech border to the Bodensee, and that takes you less than 15 minutes. This is enormously fast. This also shows how reactive air defense forces must be and how integrated they must be in order to counter especially surprise attacks. And that's why this integration aspect of air defense is so important.
Lect allows NATO and the nations to manage air operations both over NATO European territory and out of area when deployed. It combines the planning, tasking, and execution of all air operations by integrating functions such as aircraft control, air traffic control, command and control, and airspace surveillance, amongst others. ACS is replacing NATO and national systems and will interconnect more than 20 military aircraft control centers, including the Headquarters Allied Air Command, otherwise known as AIRCOM, in Ramstein, Germany. AIRCOM delivers air and space power for the alliance. Its mission is to protect the NATO European airspace on behalf of the Supreme Allied Commander Europe. This responsibility is delegated to 2 combined air operations centers, KOCs, in Torrejón, Spain, and Udine, Germany, as well as 1 deployable air command and control center in Poggio Renatico, Italy. ACS will interconnect these 3 KOCs in the future, increasing the effectiveness of NATO air operations. The Italian Aircraft Control Center in Poggio Renatico was the first ACS site to achieve operational status in May 2015.
In Italy, as a country, the beauty of ACCS is using the system for the non-real-time portion, so the planning phase of a campaign, for instance, and the real time, for instance, managing an alpha scramble for a real,
I think
for
he was
a real case.
We are one of the satellite stations of ERCOM, and we're providing with the only deployable unit for NATO that provides recognized air picture for NATO anywhere in the world, basically. We have a deployable AOC, which can also anywhere in the world provide planning of an air campaign on a small scale because we're a small unit. X is basically the operating system that we're working is. So it's an enabler for our missions. What is the most important thing is that we provide a picture to link between the tactical and the operational level. So what we do here, the picture that we provide with X can be linked directly to the higher headquarters so they know what's going on and they can take their decisions based on what X and our system is providing to the higher headquarters.
In January 2016, the NATO KOC for Northern Europe achieved early operational capability for ACS.
When the system went online here and we first started running the system operationally and trying to do air policing with it, there were a lot of people wondering if the system would just falter and fail and we would just say, okay, we'll just revert back to the legacy system. That didn't happen. So it's been pretty stable and that's been a surprise for us, but it's been a good surprise. And we've been touting that as a success.
The next sites to get ACS will be Glans in Belgium and Lyon.
Defense command and control posts in the past.
Despite initial delays, ACS is being deployed.
Knowing the programs, these merging of the ARC2 domain with the BMD, well, let me tell you, I am feeling confident that it's going to be a big success of NATO pursuing on this program. I am an operator, I am a user, but I do see that it's going to be a span to say for NATO and for each nation that is participating to the program.
Okay. So much for the NATO. Now we are seeing something from the Russia. Sıkılmıyorsunuz değil mi?
Yok hocam.
Внимание, второй, получен боевой приказ. Есть вырубка.
Вот он.
Вот она пошла.
So it's not only a pipe and explosives to make a rocket. You have to control it.
13, 111. Потом 15:49. 13, 137.
Достаточно ответственные, квалифицированные комиссии подтвердили, что порядка 70% комплексов, которые имеются на вооружении главного центра, подвержены проблеме 2000.
Игнорируется сигнал, вот этот.
This is around 15 years ago, I think.
Negative control will never be lost, and I believe them because I know that these old-style computers and especially old-style computer networks get hung up from time.
These are all drives.
Сообществу нашей
Okay, so I think you get some idea.
Внимание, второй, получен боевой приказ.
And interestingly, this is from NATO again. This is in Italy. Why am I showing this? Because my dad also worked in here 60 years ago. I actually showed the images and he remembered the salon that he was working in as an operator. And there was a Greece, Italy, and Turkey in responsibility in the room. This was the basis at that time in 1960, from 1962. The base was underground. These were the operational rooms. This was the computer. So these are the airports, military airports, and flights available in Turkey, Italy, and Greece for the NATO operations. So that there were information connection. So going back to ENIAC, it was primarily used to calculate artillery firing tables, which angles and which direction, and the wind is flowing in certain direction. So giving the coordinate, what are the angles and the positions of the artillery. Also, it is used in nuclear weapon calculations in Manhattan Project later. Thinking about software, in 1960, F4 has some software like spaceship. There were few requirements for the software. In F-16, 45% of the requirements were in assembly language. In 1980, Ada programming language is used in F-22. In F-35, C and C++ is used, and number of lines of code is tremendously high as compared to F-16. I have another table somewhere. Yeah. Total lines of code is 25 million lines of code. 7% is assembly. 5% is Ada. It's mainly C and C++. And they dropped Ada programming language because not many people were being able to write in Ada, although Ada is a superior language in terms of military operations. This is F-15, and originally Turkey was in the production partners, and we were about to take initially 100 F-35 planes. Going back to F-16, in 1984, it was 500,000 lines of code, and in 1990, it was upgraded to 1 million lines of code, and it was all programmed in Ada. Modern programming languages and software development are optimized to help eliminate bugs and security vulnerabilities that were often left to programmers to avoid. That means you are responsible for eliminating bugs. In Ada programming language, bug finding is the responsibility of programming language. So the programming language itself is written to prevent systematic bugs. The syntax of the language prevents bugs and mistakes, unlike C and C++. What are those? Simple syntax designed for human readability, structured control statements, flexible data composition, strong type checking, modular subprograms, support for object-oriented programming, generic templates, very good exception handling, meaning that division by zero kind of things are handled very well, high-level concurrency and multitasking, possibility of restricting the features for protection, so to create constrained, limited environments for only certain tasks. F-22 is one of the best examples of having Ada programming language, and about 2 million lines of code is written with Ada programming language in F-22 plane. Since the war in Ukraine is in the news, we will have some information about S-400 missile system. One of the biggest challenges in defense is when there is a missile coming, you need to find it and hit it on the air. Yeah. Is there a question? So in order to hit another coming missile or another coming incoming plane on the air, because they are flying very fast, faster than speed of sound, you need to calculate it very fast and position your rocket to meet with the incoming target on air. So it's like, it's a very difficult task because the air is so big. Thinking about the space, thinking about the air, and thinking about the size of the rocket, like a size of a car, maybe, it's very difficult to meet two cars on air. Therefore, a lot of computation and real-time control is required. Real-time tracking is required. So a radar is going to work together with the controlling the rocket on air in a very fast way so that it hits the incoming target. It is also extremely important for ships to protect itself and planes to protect itself on air and on sea, because if somebody is sending you a rocket, you have to send another rocket to meet the incoming rocket on the air. That requires computation. In S400, let me first state this way. Elbrus is the mountain, the biggest mountain in Russia, in Soviet Union. So they named their computer microprocessor as Elbrus. Fortunately, one of our department professors, our emeritus professors, Natalia Hoca, who passed away this year due to COVID, was working in Elbrus program before coming to Turkey. You all don't know Natalia Hoca because you are a new student. She left our department around 2013 or something like that. She retired. She used to work in Elbrus program. That's what she said some time ago. So it was Russian chip compared to Intel chip, and Elbrus 90 was used in S400 computer. Elbrus 90 is another system. This is Elbrus 90 microprocessor. Do you see that on the right? And this is the inside the control module of S400. So this is how you control. This is how you control the rocket. How do you control the rocket? Again, we see Elbrus 90 on the left. Because you need multiple things with S400. You have radar to track. You need controller, mobile mast, another radar, command module, and fire control radar. So basically, it's processing of radar information and directing the missile to hit the incoming target. So it's not only, these are for the rockets. It's not only the rockets, it's also the radars. So multiple tracks going together. As you remember, several years ago, I think it was 2015, I think, we hit a Russian plane. The red was the Russian plane and target, and suddenly we said it entered the Turkish territory, and unfortunately, that was the beginning of the crisis between Russia and Turkey. Although this area was protected by S400 systems by Syrians. So some people claim that S400 is capable of detecting F-35. Some others say they are unable to detect. there are some videos about it. So you will see one of the videos as follows that says F-35 can beat S-400. So let's see how it says. It's very short.
Russia's S-400 Triumph is widely touted as one of, if not the most capable air defense system in the world. With the ability to leverage a variety of missiles to engage different air threats at ranges up to 250 miles, the S-400 has widely touted counter-stealth capabilities, and it's gained a reputation as one of the few systems capable of countering America's air dominance approach to warfare. But is that true? Let's dive into the S-400 and what it's really capable of. I'm Alex Hollings, and this is Air Power. Among the heated debates that you can find on social media and in forums about aviation, the question of how well the S-400 can defend against America's stealth fighters comes up pretty often. Depending on which side of the Iron Curtain your loyalties lie, you may either see the S-400 as the kryptonite to America's stealth-focused air dominance approach to warfare, or just another overhyped piece of Russian equipment benefiting from a great deal of media manipulation. And to be clear, it's not easy to determine which it is. Russia has been intentionally opaque about the S-400's testing history. And in the few situations where the S-400 has found itself in real combat, its performance has prompted more questions than answers. So I set out to get to the bottom of this, and not just by going over publicly accessible media reporting about the S-400's development and its use in combat, but also peer-reviewed assessments from experts in a variety of nations, so I could get as broad a perspective as I could into how effective this system really is. And in my research, I came to two seemingly counterintuitive conclusions. The first is that the S-400 isn't nearly as capable as it's commonly perceived to be, but the second is that it is nonetheless one of the most advanced and capable air defense systems in use in the world today. Now, I know those seem like opposing views, but the complexity of the air defense enterprise is just so understated in media and popular discussion that it really lends itself to this sort of misunderstanding. The emergence of hypersonic missiles in recent years has really further exacerbated this unrealistic expectation that people have for modern air defenses. These fast-moving and maneuverable missiles are often touted as important specifically because they can defeat modern air defense systems. And that emphasis on their value as a means of overcoming air defense systems just sort of suggests that subsonic and even supersonic missiles can't. But that's not true. Intercepting any missile is a very difficult proposition that no air defense system in the world can manage with 100% efficacy all the time. Now, as is often the case, my full-length analysis into the S-400 is just too long to fit all in one video, but you can find it on sandboxnews.com. So if after you watch this, you want to dive a bit further into the nitty-gritty details, I definitely recommend you check it out. There will be a link in the description below. But now let's get down to business. Development of the S-400 probably began in the 1980s, but the effort wasn't revealed to the public until 1993, which you may note was 2 years after the collapse of the Soviet Union. Like many former Soviet programs that saw continued life under the newly shifted to accept the idea that it may be about this specific set of circumstances. Without over-the-horizon sensors, the S-400 and other powerful HIMARS systems are vulnerable to a low-altitude attack by cruise missiles, which in large numbers can overwhelm an air defense system. And that line-of-sight problem can be made significantly worse by geography. If you're fighting in a mountainous area, it gets even harder to detect those low-flying threats. Now, a Russian S-400 battalion usually consists of 8 missile launch platforms, each of which is armed with 4 missiles. Now, regardless of the missile types, that means that at best, an S-400 battalion can intercept 32 targets before it runs out of interceptors to fire. With an outside range of 400 kilometers or 250 miles, that means that even data to back. Oh, does all this really is through show how important mission planning really is for?
So, you can watch that later. I gave the link. Some people say it is superior. Some people say it's not as superior. But you all understand that radar technology, signal processing technology, and fast computation, together with the correct control, will result in successful weapons for air defense. Oh, sorry. Okay. Any questions before I move? Here is our last video. Thinking about electronic warfare. Electronic warfare is more about jamming, detecting, and signal processing. And one of the planes that are famous with electronic warfare is F-18. So here we have some small introduction to F-18 plane. Oops, sorry.
EA-18G Growler, the king of electronic warfare. The F&A-18 Super Hornet Block 3, or Advanced Super Hornet, is the newest highly capable, affordable, and available tactical aircraft manufactured by Boeing Company. The combat-proven Super Hornet delivers cutting-edge, next-generation multi-role strike fighter capability, outdistancing current and emerging threats well into the future. EA-18G Growler is a derivative of F&A-18 Super Hornet Block 3 developed by American defense giant Boeing Company. Multi-band jammer. The Super Hornet can carry Advanced Electronic Warfare (EW) pod. Currently, the U.S. military's premier EW platform is the EA-18 Growler, an EW version of the Super Hornet where Boeing has taken out the gun and installed more EW equipment. Instead of missiles on the wingtips, it has a large sensing pod. The jammer on the EA-18G Growler is the ALQ-227, a multi-band jammer effective at standoff ranges and within the engagement range of HARM anti-radiation missiles. The Growler is fitted with an integrated defensive electronic countermeasures system, self-protection jammer pod, radar warning receiver, decoy and data link transceiver. The EA-18 Growler has been used in the Syrian and Libyan war to defeat Russia's air defense systems. The primary means of defeating S-300 and S-400 in air defense system is to use the EA-18 Growler. The EA-18G Growler is an incredibly capable and critical weapon system that provides electronic attack capability to the US and Australian Air Force. The EA-18 can disrupt, deceive, or deny a broad range of military electronic systems, including radars and communications. The EA-18's ability to locate, record, playback and digitally jam enemy communications over a broad frequency range using its ALQ-227 communications countermeasures set. America's premier electronic attack aircraft, the EA-18G Growler, is an antidote to first-class air defense systems, particularly the S-400. The EA-18G can obtain enhanced radar image resolution, targeting and tracking range through its APG-79 Active Electronically Scanned Array, AESA, radar system. Once adversary ground-based and airborne radars are jammed, the EA-18G can eliminate modern threats such as stationary and mobile air defense system threats using AGM-88 high-speed anti-radiation missile HARM. The EA-18G Growler can defeat most Russian and Chinese origin A2 and AD systems such as HQ-19, HQ-22, HQ-16, S300, VOOC, and S400 systems through the use of SEAD and DEAD missions. Thanks for watching. Please subscribe to.
Now we are done. Let me go back to Apollo computer. That's one of the first computers in avionics. It had, yeah.
Can I ask a question about
Yeah.
previous video? Can these planes affect their own electrical waves?
No,
Or
it is
just defenders?
It is directed.
Okay.
And internal electronics is not wireless, so it is only affecting radar detection systems. They are not making S400 systems to explode. They are just making them unable to operate. So unable to operate, that means through the signals, not through the harming the electronics of S400 systems. It's not yeah.
Can I ask a question about the S35s? We were talking about how the Ada programming language is better at preventing, systematic errors. Why did they, for the S35s and the recent technology, why did they move towards C and C++?
I read a lot about that. The article said due to programmer availability, not many people were knowing Ada programming language, so they couldn't recruit enough people. They need thousands of programmers, engineers. So those engineers are not experienced in Ada programming language. Then they decided to go with C++ instead.
I see them. Thank you.
This had operating frequency of 2 megahertz, 15-bit word length, and 36 kilobyte of RAM, core memory, and 55 watts of power. So it's an interesting computer. There is a video about it made by MIT. In terms of communications, military operations require encryption for communications. So you need to encrypt the messages in the wireless communication. Plus, when you are communicating, remember these missiles, they are built on trucks. Why they are on trucks? Because they have to move continuously. If they don't move, they will become targets. So when you are making communication from one location, your location can be detected. Therefore, you need to move to a different location and operating. Some rocket launchers are mobile rocket launchers. They launch rockets, they move, they launch again, because based on the rockets detected on the radar, they can find your location. So as soon as you finish launching the rockets, you immediately move. Otherwise, they will bump the location. The other side will bump the location. In order to prevent location finding, another technique is to make frequency hopping and spread spectrum. Spread spectrum means you are not only using one frequency, because if you are using one frequency, it can be detected, and location finding will be easy because power in that frequency you are emitting is detectable. However, if you are communicating through predefined different frequencies with each other, by changing the frequencies, that is called as frequency hopping. Location detection and listening will be difficult, because the enemy should know what patterns you are changing the frequency. Then they have to lock on your frequency hopping. So it's an important technology, and finding the founder of that frequency hopping technology is actually a woman, also an actress. Who was she? I forgot the name. I'm going to check. Hedy Lamarr. Hedy Lamarr is a Hollywood actress, also is the inventor, has the patents for frequency hopping that is used today in Wi-Fi and Bluetooth, and also in GSM. This woman. Also, as we have seen in the recent earthquake, there is also administration and operational requirements. So tracking the meal plan, cooks, fees, payments, etc. So military operation is like financial organization. It's an organization. So organizational requirements, organizational tasks are also performed within the military. Not only, for example, they get sick, so they have hospitals, they have kitchens, etc. So procurements, they have vehicles, maintenance of the vehicles, etc. So they all different requirements. For those tasks, there are also computer systems and software, and there are companies who develop software for military operations. Askerlik şubesi. I have about 10 slides more. One of them is one of the remaining things is guidance and tracking. So self-guided, computerized guided weapons, autonomous weapons, drones, etc. So when we think about drones, don't think about quadcopters because they have to go fast. Therefore, rocket drones are also possible. They go by themselves with the camera. Avionics means, it's a common term. Avionics means aviation and electronics together, and computers. It could be simple or it could be significantly complex computer system. All of them are called as avionics. There are some departments in universities dealing with avionics. Those departments are usually having teaching programs for making technicians rather than engineers. With machines becoming more difficult to use, soldiers are expected to use computers more. They need to operate sophisticated equipment. So computer literate soldiers are necessary because if not maintained and operate correctly, then they will be unsuccessful. So wartime user interfaces, situational awareness issues are important. Interfaces in the tanks, interfaces in the planes, and also interfaces used by small equipment by the soldiers are interesting issues because in the wartime, your adrenaline is higher and you are frightened, so you have to use the interface, you have to use the computer. So it's not like using the mouse and desktop interface. You have to be quick and correct. There is no room for the errors. Also, there's computer use for simulation. There are war simulations. You are familiar from the games and flight simulators. Simulators are important part of the military computing. Simulations for tactical cases and simulations for flight and driving vehicles. So those kind of primary simulations are also simulations for the generals. This is one of the examples, decision support systems combined with the simulations, information flow, and together with the data visualization, commanders. Evet o şey. Savunma Bakanımız. Sağdaki. Commanders and military leaders make decisions based on the information flow. So decision control systems are significantly important. There are new technologies like drones and cyber suits that helps soldiers, including exoskeletons. See, exoskeleton. So you wear it. So when you wear it, you can hold more weight. You can carry more. It's a robotic piece of equipment you wear behind your back. So it allows you to carry 100 kilograms. And also more autonomous systems. Through United Nations regulations, autonomous firing weapons are prohibited right now, as far as I am correct. But nobody's big players are not following that, just like nuclear act. So in the coming years, we will see more and more autonomous firing weapons, which will be very dangerous. One of the earliest autonomous firing weapon is what? Landmine. Landmine is typical autonomous firing weapon. You place it, and if you hit on it, it explodes. So it's a simple trigger mechanism. So that's also banned in many treaties. Also, autonomous firing weapons are very dangerous for future. Wearable sensor systems, vision systems, and data processing systems together with the soldiers and security personnel. So if you are going to develop a project in future or graduation project, there are possibilities for you to develop such projects. Smart guns for finding the target more accurately, laser vision and computerized camera processing and stabilization, image stabilization, etc. Automated shooting. These are called as smart guns. And let me explain what ruggedized specs are. Regular commercial system is capable of operating 0 to 70 degrees. Industrial systems and automotive systems are capable of running over 100 degrees, 105 degrees. Then military systems are capable of minus 55 to 125 degrees. So when you look at the chip, this is a famous chip, 555 oscillator chip. It has versions. So when you look at the chip name, NE55 555 is the commercial name. ICM 7555M is the same chip, but military specification. Again, for example, LM324 is an operational amplifier, an electronic circuit, small electronic circuit. It has LM124 is military version. So each manufacturer manufactures high quality components for military computer and electronic circuit making. As I said, unmanned operations are important. We will see them more and more in future, and you are also encouraged to study on these issues, because not only for defense or fighting, but also for security, homeland security, for the police, for homeland security, these systems are very beneficial. While the last thing, while you are on the battlefield, there is a need for power. This power can be harvested from the sun, from the batteries, from the hand cranking, from the fire, thermonuclear energy, sometimes nuclear energy. So power consumption is a factor. All generating power, also the use of power. The use of power must be minimum so that it will be operated by the battery. So trend for smaller, lighter, and more power efficient systems is essential for military systems. Power management, shutting down non-critical systems if the power is low, is interesting. Power management is a topic. There is a video I'm not going to show. This demonstrates how mobile rocket launcher operates. And if you have any questions remaining, please let me know for today. I am stopping the recording.